Hello there, my name is Christian Alfoni and I am the author of the library Cerebral. And to talk about Cerebral and give you a good sense of what it is and why it was built, we're going to use Yoda here. And think of Yoda as an application. And what we're actually going to do here, we're going to pull Yoda's finger and we're going to talk about how the butt reacts to that. A bit silly, but it actually works pretty well. I'm also going to use the terms model layer, view layer, and controller layer. And do not think of this as like hardcore MVC pattern. I'm using these terms because they are very fundamental. Because our applications needs a place to put their state. It needs to store state. Applications are stateful. And that is what I call the model layer. And then we have the view layer, which is UI and handling interaction. And then we have the controller layer, which is actually the part of your application that receives some interaction data and then triggers like a state change flow. Sometimes a state change is very simple, but very often it's a flow of many things happening. And the end result of that is to change or store some new state in the model layer. And then it goes back to the view, and so it goes around and around. Okay, so as I said, think about Yoda here as an application. We're going to have a finger view, and we're going to have a butt view. And we're going to pull Yoda's finger. And we can do this in different ways. We can use imperative programming to do this. And what that means is that if you think of these two views as two different files, the finger view in this case will have a dependency to the butt view. And when the finger is pulled, it will actually call a method on the butt view to kind of like do its thing. But there are problems with this way of doing things, because if you look into the butt file, you have no idea that it's a dependency to something else. So it's very hard to reason about your application looking into the file that, in this case, the butt file. It also causes problems when you change that file, because since you don't know what methods are called on it, it's very easy to break stuff. Another thing is that if these two views start to depend on each other, like both of them needs to call methods on each other, then you get circular dependencies, and that is a problem. There's also a question of scalability here, because every time you want something else to react to pulling Yoda's finger, you have to go into the finger view and call methods on the other views. So it's just harder to scale. Another thing is that these views does not necessarily know about each other's internal state. So if the butt view changes its state, it will need to tell the other view about that state change if it needs to know about that. So you have to synchronize state, and that is very, very difficult to do. And also, if we think about this in a more anatomically kind of matter, it does feel a bit strange that when you pull Yoda's finger, the finger tells the butt what to do. It just doesn't make much sense, really. But there's a different way to think about this, and that is using reactive programming. So now we kind of like flip things around, and now the butt view has a dependency to the finger view. And whenever the finger is pulled, the finger view just emits an event. And the butt view will listen to that event and call a method on itself. And this makes it easier to scale, because any new view, you don't have to go into the finger view and call methods on the new views. They can just depend on the finger view, listen to the finger pulled event, and call their own methods. So it's easier to scale. But again, it's easier to handle the order of things, because it depends on when you register the listener to the pulled finger event. As in the previous example, you could first we call that view, then that view, then that view. So there are issues here. And we still have this issue of circular dependencies because these two views might need something from each other, listen to something on each other, and we get circular dependencies. And again, we have to synchronize the state. If there's one state these two views needs to share, then we have to synchronize that to make sure it's the same on both views, and that is really hard to manage. Also thinking about the anatomy here, it's kind of strange that the Yoda's butt is listening to the finger and reacts to it being pulled. So let's move on here and see if we can make things seem a bit more natural. Okay, so now we're going to talk about introducing a controller layer. So we introduce a controller layer that helps us handle the state change flow of the application. And in this case, the controller layer is just an event hub. It's just a file that has like an object that can have listeners on it, and you can emit events on it. So all the views depend on this single event hub, and they can emit events on it, and they can listen to events on it. And this solves a few things, because now we do not get circular dependencies, because everything just depends on this event hub, which is really great. And it's very easy to scale the application, because you can just add a new file, depend on the event hub, and you can listen to any events you need, and you can trigger any events you want to trigger. The problem here is that we still have problems with state, synchronizing state. First of all, when the application runs, you can't have like initial state of the application where you need to share it. So if two views needs to share some state, you cannot guarantee that that will be in sync when the application starts. They can start to communicate with each other, and you can try to keep it in sync, but it's really, really problematic. And it's incredibly difficult to reason about this sort of application, because if you go into the event hub file, it's just an object. You don't know what views are listening to what, and which views triggers, and what views actually has some interaction with each other. You have to check all the view files, and it's just, yeah, it gets crazy. It's not very good. But what's good about this is when we think about this anatomically, it starts to make a bit more sense, because now when you pull Yoda's finger, it just tells the controller layer that, hey, my finger has been pulled, and it emits an event, and then the butt can listen to that and react to it. And then we got this new thing called Flux. And what's really great about Flux is that we got some state outside our views. So now when we start our application, we can define lots of state, and all the views knows about that state and can use that state. And when we change the state of the application, a view can just call something called a dispatcher, pass a value on it, and that dispatcher will send this action into the model layer, and there it will change the state. And then any views can listen to state changes and update themselves. So this is a really, really great way of thinking about things. Again, it's still possible to have state inside the views, but Flux encourages you to move as much state as possible outside the views, because it makes things so much simpler. And I think the main reason this works very well is because it doesn't have any crazy abstractions. It's just objects, arrays, boolean, strings, numbers, and stuff like that. When you compare that to other frameworks, specifically frameworks, they have these crazy abstractions where you have models, collections, and it's often always related to data on the server. But we got so much other stuff we want to share across our views, and Flux makes that very, very easy to do. And again, this is kinda anatomically correct again, though it's a little bit strange that the view in this case with Flux would dispatch an action telling the bot what to do. So we're kind of moving a bit away from the previous example, but there are more important things that does not work too well with this Flux solution. But before we go into that, I just want to make sure that I give this shout out, because Flux changed the way I think about applications, and it made a huge difference in how I develop applications and think about application development in general. So big shout out to Facebook and the Flux team. Awesome, awesome job. But if we zoom in on this model layer and the controller layer is a dispatcher. So the views, they call the dispatcher and they can pass an action. An action is just telling the dispatcher what methods should be called in the model layer, where we have these stores. And you can pass a value on it. And then the dispatcher dispatches this action and it goes into the stores. And these stores will now handle that action and do the state changes. The problem here is that now we're starting to get the same issues we had with our view layer, because we have multiple entities representing state handling, and these quickly start to depend on each other. So we get circular dependencies again. And we also have this issue where a dispatch wants one store to react to that dispatch before the next store. And then we have this wait for method, which handles that to make sure the order is correct, but it's so hard to reason about. And when you do stuff like that, you're not able to do asynchronous stuff. And it's difficult. I think it's really, really difficult. So I like the concept of Flux with the one-way flow and having state inside this model layer and stuff like that, but stores and the dispatcher, it's hard to reason about. But the community started giving feedback on this, and things got a bit better, because we got these action creators. So instead of the views calling the dispatcher directly, they would call these simple functions. And these functions would do kind of like handle state flow or state change flow, like calling the server, doing async stuff and all that. And they would do multiple dispatches into the model layer, into the stores. And this helped a lot, actually. But now it helped, but it didn't make it easier to reason about your application. Maybe it even made it even, I wouldn't say worse, but it didn't make it better, that's for sure. Because now you had state change logic to different places, inside your stores and inside your action creators. But then something happened. And that is, to me, that was the library Baobab. And what Baobab did was remove this, it's just a single entity inside your model layer. It's a state tree. So it's basically just one object that you can just shove all the state of your application into. So it removes all these problems I just explained with stores. And it doesn't need a dispatcher, because you don't have to handle the way you pass information into the model layer. It's just putting stuff into the tree. So now our controller layer just becomes these functions that are called action creators. But now they're not really action creators because you're not dispatching actions. You are just doing the same stuff you did, but instead of dispatching actions, you do state changes on this state tree. And all the views can listen to this state tree and react to changes to it. And this was also a big moment for me. Finally, Flux worked the way I wanted it to. And it's so easy to reason about your application, because you don't have lots of logic in regards of state change. You just have these functions inside your controller layer that does all the state change flow logic. So there's no logic doing state changes inside your model layer. It's basically just an object. Really cool stuff. So I also want to give a shout out to the Baobab project. It's awesome. You should check it out. And now we are beginning to close up on Cerebral, because now our controller layer is we have kind of like solved the view layer. The view layer with especially React is really awesome, and with this single state tree in our model layer, I feel that's also working out pretty well. And what we have left are all these functions inside our controller layer that handles the state change flow. And this is a typical example of that. A function called getUser. And what it does is setting some loading state inside our tree. It fetches a user from the server. If it's a success, it sets the user, reverts the loading state, or if there's an error, it will of course set an error instead and revert the loading state. Now, the problem here is that the name of the function doesn't tell what it does. You have to read the implementation details. So if the name would suggest what it actually does, it should not be getUser. It should be like set loading, getUser, if success, set user, revert loading state, yada yada yada. I'm just trying to make a point here. Things have become so much better, like in the big picture. But if we look at this function, things are starting to get very hard to reason about again. So yeah, you have this name that doesn't tell you what it does, and you have to read all these implementation details. And this is a very simple function. You could have lots of functions being called from this one function. You have to jump into those files, and it would just, be a big problem. So this is exactly where Cerebral fits in. Cerebral tries to solve this controller layer. It tries to give you a very good concept of handling state change flow, because most often it's not just changing a single state. There's like a flow of change that could be expressed a lot better than what we see here. So Cerebral, a state controller with its own debugger. Let's see here. So now the main thing in your application, if you kind of like, the views are the most important part, but if we go up from those, we have this controller layer, and the controller layer is one entity. It's a controller, and that is what handles the state change flow of your application. So the views are able to tell the controller layer when something happens, but it can also listen to the controller layer and be told when they should update themselves. What's kind of special about Cerebral is that the views doesn't listen to the model layer. The model layer is just an implementation detail that Cerebral needs to store state. So it's only Cerebral that talks to the model layer, and that can be different kinds of model layers. But it's actually Cerebral that tells the views when they should update. And that's really nice, because now the views doesn't update on every state change. They update when Cerebral tells them to do. So it's more like when a state change flow is finished, not when the single state change has been performed. Which is like in practice, we're talking like sub-millisecond optimization, but in theory it just makes more sense, really. Yes, so that's what I wanted to talk about in the broader sense. But if we move into this function again, because this is what we're trying to solve, these functions we have to express our state change flow. So we have this getUser doing all this stuff, but in Cerebral we have something called signals. So you can think of signals as like an abstraction of these functions we are used to creating. And a signal starts out with a name, and the name of a signal should always be what happened in the view layer. And this is really important, because when you read a signal, you should know what happened in the view layer to trigger this signal. And as we can see here, this signal is called app mounted. So we know that when the app mounts or fires up, it will run this signal. And a signal takes arguments. And the arguments are functions normally. So an action in a signal is basically just a function, and it's a pure function. We will see those actions very soon. So in this example here, we have an action called setLoading, which will actually set the loading state of the application. Then we have an array, and then an array indicates that the actions inside this array are asynchronous. The first item in this array is also a function, but we're calling it. So this is just to give you an example of how you can use factories. So we are getting some functional traits here. So when calling this get function, it will return a function using that URL we passed in. So you can kind of create like a server gets very easily. And you can compose this stuff and reuse all the function on all the signals. So it's kind of fun to build these signals and actions because they are like Lego blocks. Very, very fun indeed. Yeah, so that's an example of a factory. But the next item in this array is an object. So any action can take different paths. So in this case, if we actually get the user and it's a success, it will run a set user action. But if it turns out there's an error on the server, it will run the set error action instead. And when after this array, it's a normal action again. And this action will run when the array is done running. Like the asynchronous get is done and either set user or set error has run. Then the last argument will run. And as you can see, this is a lot easier to reason about. You see what happened in the view layer, and you can very quickly see what does this signal do. And this is a very simple example. It can get crazy complex, but you still have this really nice abstraction that tells you what's happening. And that is because it doesn't have any implementation details. And there's very few places where you have this kind of overview, where you can see what is happening in your application without looking at the implementation details. And I think that's really important to have, or else you will have a hard time reasoning about your application. So let's dive into these actions. So if you look on the left side here, I have changed from get to get user again, so it's just a normal action. So these actions, as I said, are pure functions. They do have side effects in the sense that they will call methods on this state object. I will talk about that very shortly. But that doesn't matter in regards of testing, and that's really important. It's the testing part. It's very easy for you to mock out these arguments passed into the actions by the signal. So it's very easy to test them. So in this first action, we have set loading, and it receives an input argument. And input is what you get from triggering a signal. But you will also be able to get input from other actions. So an action can make an output, as we will see on the next action, but it doesn't output to the next action. It outputs to the signal. So all actions outputting something can be accessed by all other actions after it. And that is accessed on the input argument. And then we have the state argument, and this is like your endpoint to the model layer. This is where you do your state mutations. In this case, we are just changing the value of isLoading at the top level of our state tree. If we were going to dive into the state tree, we would use an array instead of a string as the first argument there. Okay, and then we have the next action, and that's getUser. And this action will run asynchronous, and it will have an output. But next to the output argument, we also have an argument called services. So what you can do with these actions is to kind of like inject different utils, like you can choose your favorite Ajax library, underscore or Lodash, or whatever you need to handle the state change flows. And what's really nice about that is that it's really easy to mock those things too. But in this case, we are using just a service called Ajax, which gets some data from user, and then it outputs to the success path. And the response from this server will be like an object where you have user as a property and the value of that. So that user property with its value will be put onto the signal as an output and will be available to all other actions as an input. But if something goes wrong, it will output an error instead, of course. And then we have this set user action, and as you can see, we are using the input .user here, which we got from the get user action. So you get this really nice state changing flow, and the implementation details are very isolated. So it's very easy to reuse all these actions. What you also can do, which I don't have an example of in code, is that you can define what outputs an action expects, so that when you use these actions in a very complex application, you will get an error if you use them wrong, because they do expect certain outputs in the signal chain or the action chain. You can also type check these outputs, and you can also type check the inputs. So you can, when you're working on bigger projects and with a larger team, you can do these checks to make sure that you do not break stuff. And again, if you add unit tests to these functions, then you are secured. You should not have any big problems scaling your application. So now we have gotten some insight into how Cerebral works and why it has been built. So with this in your mind now, we are going to take a look at a to-do MVC demo here. And what's really cool now is that you have no idea of how the code looks. But if I start typing something here, you will see in the debugger on the right side what is happening inside Cerebral. So what it says is that we trigger a new to-do title changed signal, and that triggers one action called set new to-do title, which does one mutation on the new to-do title state, and this is the value. So you get a lot of information about the state change flow, which is the really difficult part to get your head around. You get in the debugger. And I can hit enter here, and we can see a much more complex example where we also see the outputs of different actions, and we can see that one action was asynchronous and it had a success, and so you get a lot of information. And you can also click these different values and properties and stuff like that to take a closer look. If I, for example, click that one, you see down in the console, we get all the information we need. The milliseconds here is related to how long it takes to trigger a signal and actually update the view layer. Now it says 50 milliseconds, but I'm on a slow MacBook and running Camtasia and everything, so yeah, it's pretty slow. You can also, but it's there to give an indication. That's really important, just an indication. We can also click the model here to get a complete overview of our of the state tree, and we can also grab this slider to go back in time. And this is kind of cool because you can verify the state flow when you have lots of things happening. We can also refresh the application, and it will actually reproduce the state. So this is really great when you are developing. You can do changes and refresh the application, and you don't have to reproduce the state to verify that your code change did what you wanted it to do. What we also can do here, which is pretty cool, is that we can hit the record and say, hey, I can stop that, and when I play that back, it will just honor the time it took between triggering the signal. And this can be used for lots of different cool stuff, but we won't go into that now. So yeah, this is what I wanted to show you. I hope this was a good introduction to Cerebral, and I hope you will try it out and check the other video on how to actually implement code and create your own Cerebral application. Thank you.